Hello guys, and welcome back to another episode of my channel. And today we are going to be talking about Metre Bridge because we have an exam coming up, a practical exam, and I want to help all of you do very good in that. So, Metre Bridge. Now before we start, we have theory and practical, both of which we need to do. Okay, we need to do the theory and the practical. Why? Because if you do the theory, only then will you understand the practical, and if you do the practical, only then will you understand the theory. So it's kind of interrelated. Okay, so let's not get into too much fuss because I want to make this video short and I have to explain 2 experiments plus the theory. So I will do this very fast. Okay, so this over here is a Metre Bridge. I have drawn it directly. Let me just pull my camera a bit close so you can see. I don't know if you can see. Yeah, alright, so this here is a Metre Bridge. Oh, there's a light falling on it. Let's see if I can fix that. Alright guys, sorry, I fixed the lighting. So you can see behind me the Metre Bridge, right? So now what is this Metre Bridge? Let me just quickly explain it to you, every component of it. Okay, oh my god, the cars are honking. Okay, so there's a battery. You know what a battery is? Of course, there's a battery. It's connected to a key, and this is a variable resistance. It's a rheostat. Okay, it's called a rheostat. In the practical lab it looks like a cylinder. That is the rheostat. Okay, now what I am going to tell, pay attention. Okay, this is connected to a L-shaped metallic strip on both sides. You can see both sides the L-shaped metallic strip is there. Now this is connected in the left gap. This is the left side. You can see L, right? So this is the left side. This is connected in the left gap, and this is connected in the right gap. What is this? RB is the resistance box. Okay, there's a box in that there are like key like things you put inside and put out. That is the resistance box. X is the unknown resistance. Okay, they'll give you this unknown resistance and you have to find it. And this is a galvanometer connected to the jockey. Everyone knows. Okay, so what is the use of this? Also, there's a scale. There's a scale over here from 0 to 100. That's a meter scale. This is a very bad diagram of a scale, but okay, whatever. Now only thing that you need to know is that Metre Bridge is an application of a Wheatstone's bridge. This is theory. Okay, so what we get from that is that when this is in a balanced condition, we get that X upon R is equal to, where R is the resistance box. The resistance in the resistance box is R. So X upon R is the resistance across AD, this is AD, upon the resistance across DC. So resistance of a wire, and the formula for a resistance of a wire is rho L upon A. Now this rho and this L, this rho and this A will get cancelled, but the L will remain because length is going to be different between both sides, Lx and Lr. So you will get that X upon R is equal to Lx upon Lr, and then you will shift this R over there and you will get X is equal to R Lx upon Lr. You will need this formula in practicals. It is very important, okay, for the exam also. Now I'll just quickly refer to the practical textbook and come back with the table drawn, and I'll tell you how you're going to go about the experiment. Okay, I'm back. So see what have I written. This formula we just derived, so I wrote this xs and xp. Now what is this? Now x is the resistance, the unknown resistance, right? Now in the lab, this unknown resistance is given to you in the form of two boxes. So you'll get one box and you'll get two boxes. ऐसा दिया रहेगा, and you have to connect them first in series, then in parallel. So when you connect them in series, they will diagrammatically look something like this. See, one resistance and connect it to the other resistance. Call this R1, call this R2. Okay. Second, no wait, we'll call this X1, X2 because we are using that, right? So X1 and this is X2. The second way you are going to connect them is parallel. This you have done in theory, okay? So I don't think it should be of much worry here. This is now, in this case, this is X1, this is X2. Now if you want to find equivalent resistance of this, then you will use this formula. Xs is equal to X1 plus X2. And if you want to find equivalent resistance of this, the parallel, then you use this formula. This you have studied even in 10th standard, so I don't think it should cause much issues. Now what you have to do in this experiment, पहले connect it in series. Okay, now you have to try to understand that this is the left gap and this is the right gap. Okay, so what you have to do in this experiment, is you will get those resistances, you will know their values. Matlab they will tell you ki x1 is equal to say 50 for this example and x2 is equal to 100. Okay, they will give you, it will be written on that box. So 50 and 100, of course the value is ohms because it's a resistance. Now what you have to do is you have to first connect this in series. You have to connect this in series. Now when you connect this in series, you'll put it in the left gap. In the left gap when you put it after connecting the circuit. Okay, after connecting the circuit you have to put it in the left gap. Now I cannot show you visually how to connect the circuit, so you can refer to other videos, there will be many, I'm pretty sure of it. Okay, but okay, once you connect that in the left gap, these two in the left gap in series, then you will find excess. You will take the jockey, you will point it on that scale, and you will find a point at which the galvanometer shows no deflection. Galvanometer 0 पे रहेगा. Okay, and that's it. Once you find that, you will calculate this distance as Lx, this distance as Lx, and you will calculate this as Lr. Okay, so you will get your Lx and Lr, then you will put it in this formula, this one right here. I'll just mark it, this one. And when you put it in this formula, you will get xs. You will get xs. Now how do you know what resistance should be taken in the resistance box? That is a good question. You have this x1 and x2, so you calculate xs on your own. So you will get 150. Okay, so now when you are finding, now that you have got 150 here, when you are finding the what to put over here, you get this 150, right? This is not a point, it looks like a point. Yeah, 150. Now this 150 के आसपास you have to set this का value. So I will set it, if I got this as 150, I will set it 5 below, I will set it at 150, and I will set it at 155. So this way I will be able to find. So once I put these resistances, then I start the switch. That time the galvanometer will show 0 deflection on a certain point. Okay, we will balance it on a certain point. When that balance appears, we will note down our Lx and we will note down our Lr. Then once we note that down, we will multiply it with the R and divide them by each other, and then you should get a value. That value will be your xs. Is ऐसे you will get 3 xs for different 3 of these. Okay, this is for left gap. Now in right gap again, now what you have to do is you have to shift this x from here to here and the resistance box from here to here. बस उतना ही करना है. And now again you will take the same values, 145 and 150 and 155. Again for all of these you will get a certain xs wala value. Now from those 6 of them, take a mean. You know how to take a mean, right? So if you get 1x, 2x, you will add all these, whatever values you got, you will get 6, right? So you will add all 6 and you will divide that by 6. Number of observations, no sorry, sum of observations upon number of observation. Okay, that is how you find the mean or the average. So when you find mean x's, that is done. Now you will use parallel. So when you are using parallel, you have to connect the two boxes in parallel. Okay, once again I'm saying, to see how to connect the circuit, watch another video because I cannot really show you visually over here. I do not have the equipment. Okay, in xp, again you calculate it, use this formula. Now when you do that, you will get the answer as 33.33 something approx. Now you cannot remove 33 from this 33.33, so you will obviously round it off to 32 or whatever, 32, 34, 30. For this you take in the left gap, in the right gap, then find the mean xp. Now what you will get is that when you calculate, your mean xs should be close to this. So it should be very close to this answer that you got. So this is your theoretical xs and this is your experimental xs. Similarly, when you calculate xp, you will get the theoretical and the real mean xp which you calculated during the experiment, and the more close these are, the better. Okay, so that's it for this video. It's gone to 10 minutes already. That's how you basically perform the meter bridge experiment. Again, for learning the circuit, watch another video. I'm pretty sure there'll be many. If I find any, I will link it down in my comment section below. Okay, bye and take care.